Lesson 4, types of solutions and the solubility curve. So the types of solutions. We have unsaturated solutions, which means you can actually dissolve more solvent or more solute in the solvent. We have saturated solution where the solvent holds as much solute as it possibly can. And a supersaturated solution is when it has more solute than the solvent can hold, and this is very unstable and it will tend to create crystals. So one of the things we're going to look at is solubility curves, and so you'll need to actually look at table G in your reference packet. And if we're looking at, let's say, potassium nitrate, and potassium nitrate, this is the solubility curve. It basically tells us at what temperature can we dissolve and how much can we dissolve in water. So if it falls below the curve, it is unsaturated. If it is on the line, it is considered saturated, and anything above the line is considered supersaturated. So the gases on table G, 3 lines show decreasing solubility with increasing temperature. These 3 lines represent gases. It's ammonia, hydrochloric acid, and sulfur dioxide. Remember, the solubility of all gases decreases with increasing temperature, and remember why. We did that with the last unit. So to determine this type of solution, we need to look at table G. We need to locate the temperature in the question, go up the temperature line, and stop when you reach the grams of solute in the question. If you stop on the curve, it's saturated. If you are under the curve, it is unsaturated. And if you are above the curve, it is supersaturated. So example 1, what type of solution do you have if you dissolve 50 grams of sodium nitrate at 30 degrees Celsius? What type of solution did you make? Well, if we look here at our curve and we find sodium nitrate, which is up here, and we are at a temperature of 30 degrees. So we find 30 degrees, follow our line up to our curve, and we are at about 95 grams. So what we have is 50 grams, so that is less, so therefore it is an unsaturated solution. So how much will dissolve? According to table G, what is the maximum amount of potassium nitrate that can be dissolved in 100 grams of water at 60 degrees Celsius? So we need to find sodium nitrate, and that is this curve here. And what's the maximum amount we can dissolve at 60 degrees? So here's 60 degrees, follow the line up, and the maximum amount we can dissolve is going to be about 105 grams. So now if we're adding a solute to an unsaturated solution, so if we have a solution of potassium chloride that contains 20 grams of potassium chloride in 100 grams of water at 30 degrees Celsius, how many more grams of potassium chloride must be added to make it a saturated solution? So here we find 20 grams at 30 degrees Celsius, so we are definitely an unsaturated solution for potassium chloride. And right up here is my potassium chloride line here. And how much more do I need to add? Well, if I'm at 20 grams and I am saturated here at about 35, so 35 minus 20 is 15, so I can add 15 more grams of potassium chloride to the solution. So if you're cooling a solution, now we're going to look at how much will precipitate out or fall out of solution. So a saturated solution of potassium nitrate is cooled from 70 degrees to 25 degrees. How much potassium nitrate will precipitate out? So here we've got to find potassium nitrate, and that is here. And we're going from 70 degrees C, which is way over here, and we're going to then go down to 25. So we need to subtract the difference between 135 grams, which is where we are here, and way down here we are at 40 grams at 25 degrees Celsius. So the difference is 95. So with some of the rest of the examples, I would like you to try to do some of these on your own and ask questions in class to go over the ones that you don't understand.